We often think of defense as a direct physical confrontation. It's an image of force meeting force, a moment of decisive action, a wall, a weapon, a fight. These are the symbols of active defense, designed to stop a threat in its tracks. But throughout history, some of the most effective security wasn't about stopping a threat at the gate. It was about winning the battle before it ever began. It was about knowing a threat was coming long before it arrived, stripping away the crucial element of surprise. And it was about making a place so difficult, so uncertain, and so psychologically intimidating to approach, that a would-be intruder might just decide it wasn't worth the risk. The best fight, after all, is the one that is never fought. This is the world of passive defense and early warning. And it's a world built not on complex technology, but on a deep, intuitive understanding of simple physics. Let's start with the most fundamental principle: sound. More specifically, hearing what you're not supposed to hear, and understanding why you can hear it. Long before electronic sensors, people mastered the art of acoustic early warning. At its core, this art is all about understanding vibration and sound propagation. It's about turning the environment itself into a giant sensor. Historical accounts from various frontier and rural communities describe simple, brilliant methods that weaponize the very air and ground. One common historical practice involved creating what could be called an acoustic minefield. This wasn't explosive, but auditory. Loose, dry twigs and leaves were carefully placed in specific patterns around a property's perimeter, especially in concealed areas or natural funnels. The physics is straightforward, yet elegant. The crunch of a footstep has a distinct acoustic signature. It's a sudden, high-frequency, brittle series of vibrations. This sound profile is completely different from the low-frequency, gentle rustle of wind or the softer, more rhythmic sounds of small animals. The human ear, and the brain behind it, is exceptionally good at pattern recognition, and this sharp snap instantly stands out against the ambient noise of the night. This effect is amplified by atmospheric conditions. The sound travels faster and clearer in cool, still night air, a phenomenon known as temperature inversion. Cooler, denser air near the ground acts as a duct, allowing sound waves to travel further with less distortion. This was a fact well known to night watchmen and hunters throughout history, who understood that the night wasn't just for seeing, but for listening. Another, more advanced method mentioned in some accounts of remote homesteads used taut lines or wires. The primary idea wasn't to trip someone, which could be unreliable. Instead, it was to create a massive, sensitive extension of one's own hearing, a primitive string telephone. A disturbance on a line stretched over a distance, even a slight brush, would transmit a vibration to a central point, like a tin can filled with pebbles or a small bell inside a dwelling. This is a practical application of wave mechanics. Sound travels much faster and more efficiently through a solid medium like a tense wire than it does through air. The kinetic energy from the intruder's contact is converted into a longitudinal wave that races along the line. The intruder might never see the line, but their contact with it sent a silent telegraph, a physical pulse, announcing their presence directly into the defender's home. This leads us to a more technologically sophisticated application of the same principle. The listening post concept, heavily refined in the 20th century. During World War II, with the threat of invasion looming in Britain and elsewhere, civilian defense organizations and military intelligence got incredibly creative with off-the-shelf technology. One declassified historical technique involved the humble AM radio. It was a brilliant piece of lateral thinking. Here's how it was understood at the time. A standard AM radio, when tuned between stations, produces a characteristic static hiss, what we call white noise. This noise isn't empty. It's actually the radio receiver amplifying all the ambient electromagnetic signals hitting its antenna, distant lightning, solar radiation, and countless other man-made and natural radio sources. It's the sound of the electromagnetic environment. Now, a large metal object moving through this environment, like a vehicle, a boat, or even a group of soldiers carrying steel rifles and equipment, can subtly disrupt this electromagnetic field. It absorbs, reflects, and scatters the ambient radio waves, creating a temporary shadow or distortion in the field. In the profound quiet of the night, a trained listener using headphones to isolate the sound might detect a distinct change in the pattern of the static. It wouldn't be loud, but it would be a noticeable shift, a dip, a warble, or a change in pitch, signaling movement at a distance, long before any engine could be heard or headlights seen. It was a crude form of passive radar, relying on the disturbance of background RF noise, rather than transmitting a signal of its own. Manuals from the era stressed this required immense practice, patience, and ideal quiet conditions. It was never foolproof, but it brilliantly exemplifies the innovative use of everyday physics for high-stakes situational awareness. But early warning is only half the story. The other half is passive area denial, making an approach a physical and psychological nightmare without a single shot being fired. Military history is filled with these concepts, often perfected by irregular forces fighting a superior enemy. The Boer farmers in South Africa, during their fight against the British Empire, were absolute masters of this. They rarely held fixed lines or built fortresses. They used their intimate knowledge of the terrain, the physics of the land itself, as their primary weapon. They would identify natural funnels, like mountain passes or dry riverbeds, where the large road-bound British columns were forced to move slowly and predictably. They wouldn't necessarily ambush them there immediately. Instead, they'd use the landscape to introduce friction, to delay, disorient, and exhaust their enemy. Loose rocks, known as scree, could be piled in a way to make gullies impassable for wagons, forcing hours of back-breaking labor to clear a path. Thorny bushes could be dragged to block smaller trails, channeling men into pre-selected killing zones. Distant single shots from a smokeless powder rifle would force large units to deploy for battle against a ghost, wasting precious energy, water, and time. It was a war of friction and inertia, using geography and physics to multiply their own meager forces and wear down the will of a modern army. On a smaller, homestead level, similar principles applied through what we might call psychological fencing. The goal was to subconsciously signal that a place was occupied, alert, and would be troublesome to attack. This wasn't about big walls, but about projecting an aura of preparedness. It could be something as simple as maintaining a clear line of sight from a window to a gate, communicating that any approach is observed. It could be a gate that was intentionally left to be heavy and noisy, ensuring it couldn't be opened silently and acting as an auditory announcement. Every detail, from a swept porch to a repaired fence, sent a message. Someone is here, someone cares, and someone is paying attention. Even the strategic placement and use of livestock or dogs served as a living, breathing, early warning network. These animals, with senses of hearing and smell far superior to our own, are acutely sensitive to unfamiliar sounds, smells, and movements. They would often react long before a human occupant was aware. Their behavior, a dog's low growl, the sudden alarm call of geese, acting as a reliable and cost-effective biological alarm system. The common thread through all of this, from the Appalachian woods to the South African veld to a only.We observation post, is a fundamental shift in mindset, from reactive defense to proactive awareness. It's about extending your senses using the immutable laws of physics, using solid materials to transmit sound waves more efficiently than air, using the ambient electromagnetic spectrum as a passive tripwire, using the landscape's potential and kinetic energy as a force multiplier. These methods didn't require advanced technology or massive budgets. They required observation, an understanding of how energy, whether sonic, kinetic, or electromagnetic, moves through an environment, and the creativity to harness that understanding for security. In the end, these historical tactics remind us that defense is often a cognitive battle first and a physical one second. It's about controlling information, systematically taking away the intruder's greatest advantage of surprise while securing and expanding your own awareness. It's about playing chess while your opponent thinks they're playing checkers. The ultimate goal was never to be truly impenetrable, an impossible standard. It was to be unpredictably difficult, to create layers of uncertainty, to make the cost of entry, in time, in noise, in exposure, and in psychological stress, far higher than any potential reward. So, while the tools and contexts change dramatically over time, the underlying physics of sound, light, and energy do not. The principles of listening with intent, observing with purpose, and using the environment itself to your advantage form a timeless and deeply intelligent chapter in the long history of human security. Which historical principle of early warning or passive defense do you find most ingenious from a physics or psychology standpoint? Share your perspective in the comments below.